So today's lesson, Physical Science 20, classifying chemical reactions. These notes are taken in part from mrgooch.brinkster.net. So just a little shout out to that website right there, and to Mr. Gooch. If you have a Merrill Chemistry textbook, this material is on page 228 in that textbook. So in this lesson we're talking about a classification of chemical reactions. So all chemical reactions can be placed into one of 6 categories. We're going to talk about those 6 categories today. First category is combustion. Combustion. You've probably heard of this term before. When something spontaneously reacts, spontaneously kind of explodes, or we often hear the word combustion when something is reacting violently. The key is that it's reacting with oxygen. Okay, and so just a couple notes here. When oxygen combines with another compound, and most of the time you're going to see this as a hydrocarbon with hydrogen and carbon only in the compound. So when oxygen reacts with another compound, and usually it's a hydrocarbon, so we can make that note there. Those are the ones you're going to see most often. To produce, to form water and carbon dioxide. That's the key. So you've got oxygen as a reactant, and you always have carbon dioxide and water as products. Then that's a combustion reaction. Okay? These reactions are exothermic. That means they produce heat. This is an example of one of those reactions. Naphthalene is burning, and when something is burning, as I mentioned, it's reacting with oxygen. That's really how you write burning as a chemical equation. And this is combustion. Now, one you may be more familiar with is propane, okay? If you've ever been at a barbecue and you light your barbecue, that's propane gas, right? Propane tank, you turn the gas on, the gas flows, you ignite that gas, and it starts to burn. That would be propane burning with oxygen to produce some levels of carbon dioxide and water. Okay, combustion. Category number 2 is synthesis. Okay, if we take a look at this word synthesis, the root is to synthesize, right? Or to create. So synthesis, fairly simple. 2 or more simple compounds combine to form one more complicated one. That is a synthesis. So we're creating from the pieces, those are now bonding together to make one more complicated. So you have 2 or more things combining to form one thing. That's synthesis reaction. Here's an example. Iron and sulfur produces iron 2 sulfide. Just a little note here that we talked about the diatomic 7, right? Like Cl2 and Br2 and I2 and so on. Well, sulfur, in its elemental state, it's often a group of 8. Okay, not 2. Sometimes it's 6 as well. But sulfur can exist in groups, large groups of atoms, like this. And so that's why we have an 8 here and 8 here, so this is balanced. But this is a synthesis type reaction. Category number 3 is decomposition. And really this is the opposite of synthesis. So you have a kind of larger, complicated molecule breaking down, falling apart, if you will, into simpler ones. That's decomposition. An example here, we have water breaking down or decomposing into hydrogen gas and oxygen gas. Usually when electricity is applied to water, you can separate H2O into hydrogen and oxygen gas. So there's an example of decomposition. Category number 4, single displacement. Also called AKA single replacement. All right, you might see this, you might hear me say this because that's sort of what I grew up on. So single replacement or single displacement, same thing. So this happens when one element, hence the word single, trades places with another element. So we have one substitution or replacement. So in this case, A is going to displace B. It's going to basically kick it out. And A is now going to hook up with C here, bond with C. All right? So, classic case of B and C are a couple. Well, A moves in and steals B's girlfriend. I don't know, however you want to do that. So now B is all alone. Okay? Yes, I know the teenage world is full of drama, so this may be something you can relate to, right? Single displacement. Don't worry, there's a better one coming up. So an example of a single displacement, let's take a look at this one here. Magnesium replaces hydrogen in water to make magnesium hydroxide and hydrogen gas. Now this is a good practice for you to create from a word problem. Remember, we've been working on this, to create from a word problem a chemical equation. So why don't we do that? Magnesium, okay, it's going to replace the hydrogen that is in water. So that means it's going to react with water, and it's going to form magnesium hydroxide. So you see how magnesium is going to displace the H, and it's going to make magnesium hydroxide. Now, magnesium is a 2 plus charge, hydroxide is a 1 minus, so guess what? We need 2 negatives, right, to balance with 2 positives. So there's the formula for that. And also it says that there's hydrogen gas. So remember, diatomic 7H exists as H2 always. So here is your formula. Now what we need to look at is to make sure that we have a balanced equation. So let's take a look at that. The Mg's are good, 1 of each. The O's, we have 1 O there. Oh, we have 2 O's over here. See the 2? 2 of those. So let's put a 2 there to make the O's balanced. And now we have 4 hydrogens. And what do we have over here? We have 2 plus 2, so 4. So it looks like that's balanced there. 1, 2, 1, 1. Let's check our answer underneath here. And there you have it. 1, 2, 1, 1. Okay, so that's an example of single displacement. Okay, 2 more categories left. This is double displacement. Very, very similar to single displacement, but instead of just one lone element displacing, we have 2 groups. And the ions here, that in this case you could view this as these are the 2 cations, and they switch places. So there's 1 replacement, there's 2 replacements. All right. So you've got this cool couple over here and this cool couple over here. Well, A and B get sick of each other, and so does C and D. Well, it just so happens that A is pretty interested in D. And so A and D get together, and C and B also hook up. So there's your double displacement, okay, when we have 2 replacements. And the example down here is, of course, lead and nitrate, okay, and potassium and iodine. And lead says, I'm tired of you, nitrate, so I'm going to go over, and I think I is pretty cool, so I'm going to go hang out over here. And then K says, well, I can deal with that. I'm going to go hook up with NO3, so that's where you get there. So double displacement. And finally, acid-base. This is the 6th category here. It's a special kind of double displacement. So really, it's kind of like a double displacement, except the fact that we have an acid and a base, a clear-cut acid, clear-cut base. And the acids have hydrogens that can be released, obviously. And this base has a hydroxide, okay? Now, not all bases have hydroxide ions in them. Most do. But this is a classic acid-base reaction, also called neutralization. You see here. That's what it's also known as. And the products are water, always, and some kind of salt. So it's, like I said, it's kind of like a double displacement where H and OH get together to form water. See that? And then B and A, this is sort of that ionic salt we're talking about. So when we have a double displacement and water is formed, that's a good indication that it might be an acid base. And then you're also looking for the hydrogen and the OH there. Okay, so those are the 6 categories. We can review those. You should get to know those real well. So we have combustion, synthesis, decomposition, single displacement, double displacement, and acid-base. Okay, so for those of you that have stuck around here, we do have some practice here for you. The practice here is, excuse me, I've given you some reactions, and we're going to just practice naming these or categorizing these. So here we go. Here we have NaOH and KNO3, and you may not recognize this, but this is a base, okay, strong base, And this is pretty close to being an acid, but it's not because it doesn't have this hydrogen here. So what's going to happen is we see Na is actually going to end up with NO3, this one over here, and the K is going to end up with the OH over here. So what is this? Double replacement. Very good. Number 2, we have a hydrocarbon with oxygen producing carbon dioxide and water. There's only one option for that, and that is combustion. Okay? Very good. Number 3, iron is all by itself, and it looks like it ends up with Br over here. Well, how does that happen? Well, iron kicks out Na. So that is single replacement. Here we have calcium sulfate and magnesium hydroxide, and it looks like calcium ends up with hydroxide over here. Okay, it's going to kick out the Mg, and look at that. The Mg says I can deal with that. Here you go. Going to hook up with SO4, so this is a double replacement. All right, here we've got, this is actually a base with OH there, and guess what? This is an acid here. We've got water, and we've got a salt, ammonium bromide. So yeah, this is acid-base. 2 simple compounds producing a more complicated one, that is the creation of the synthesis of lead to oxide. So that's a synthesis reaction. And we've got a complicated molecule breaking down into simpler ones. And it's not necessarily just Na and CO3, but it's simpler, right? So this is a decomp. Okay, so that's your practice there for identifying the types of reactions. Hope you enjoyed the video, and good luck with classifying chemical reactions.